Good morning, everyone. Thank you for participating in today's virtual demonstration day, the future of 3D scanning, hosted by Master Gage and Tool Company and presented by Creaform Ametek. My name is Melissa Gaffrey, and I am Chief Operations Officer for Master Gage and Tool Company. We are pleased to be a distributor of Creaform's innovative products, and today's webinar will include live product demonstrations and in-depth discussions of Creaform's portable 3D scanning products and the associated software products. The presenters today are Richard Engel, Accounts Manager for the Mid-Atlantic region, and Dave Bell, Accounts Manager for the South Atlantic region. During their presentations, you are encouraged to ask questions through the chat platform found to the right of your screen. You may type in your questions, and Rich and Dave are happy to answer your questions during a question and answer session at the conclusion of all the demonstrations. Again, welcome to Master Gage and Tools Virtual Demonstration Day, the future of 3D scanning, presented by Creaform. At this time, I will turn it over to Rich Engel to kick off the demonstration of Creaform 3D scanning products. Rich?
Thanks, Melissa. Good morning, everyone. Thanks for joining us. As Melissa said, I'm the account manager for the Mid-Atlantic area. Any questions, feel free to write them on here and we'll be glad to answer them for you. I want to give you this morning a little background as to who Creaform is and what we're all about. Basically, Creaform is a manufacturer of portable 3D scanners. We're based in Quebec, Canada, and we have offices in 13 countries with 16 offices. So you'll see that across the bottom. We have offices in Houston, Irvine, California, so in Brazil, so all over the world. We've been doing this for about 21 years now, so time's been going pretty fast. We've done about 30 product launches. So every year we try to release something new, upgrades, newer changes, newer technology. You'll keep hearing that Ametek acquired Creaform back in 2013. Ametek's a huge conglomerate across the world of technology companies, and that's how that fits into what Creaform is about. What you'll see this morning is going to be a little bit about our handheld scanners, but we also do reverse engineering and inspection softwares, have an offering of automated 3D scannings, photogrammetry solutions, and you also will see a little bit of our probing solutions that we have to offer. To begin with our handheld scanners, you'll see a little bit of the HandyScan Black Series. Several scanners within this line that have accuracies from 25 microns down to 12 microns of accuracy. Very fast scanners acquiring data at a 1.3 million measurements per second rate and can scan a variety of size parts. The scanner is also ISO certified 17025. So if you need that capability, it's there for you. In addition to this, we also have our HandyScan Silver Series. A little bit less accuracy, but still incredibly accurate at 30 microns. A little bit slower, but it's designed for someone that's using not as much for inspection, but reverse engineering or maybe a less accurate inspection. Very fast, 480,000 measurements per second, same large part size range for this one. This one's available in a red laser and a blue laser, where the black line only available in a blue laser, which allows you to have more flexibility to scan shiny, chrome, black, white, you name it, any kind of part. In addition to that, we also have our GoScan Spark, very fast scanner. This one measures at a 1.5 million measurements per second, same range of parts, but will capture color and texture. So if you're doing architectural pieces, anything for like museum quality, where you need to capture the detail, or you're trying to use your scan for marketing purposes, this will allow you to do so. And at the end, I'll show you some of the images captured with this particular scanner as well. As you can see here, here's a small range of what we can do with the scanners. This is a HandyScan in use. You're scanning everything from a helicopter to brakes to landing gears to motorcycle parts. A range that's basically unlimited for you. Simply placing targets on the environment or on the part itself allows you to scan that part. And then when you talk about the Go Scan Spark, you have the flexibility of scanning parts like this. You can scan a whole motorcycle with less targets, if any targets at all, because it will use the geometry and texture to track itself. On the left-hand side, you'll see that we have no targets on that part to scan that hood. And as I mentioned earlier, you can scan in color. So the item you see in the bottom here, this whole race car was scanned with a Go Scan Spark, capturing all the texture, all the lettering, color very accurately. Now that you've seen a little bit of our handheld scanners, I'm going to turn it back to Melissa, and you'll go over to the demo. Thanks, Melissa.
Thanks, Rich. If you have any questions about what Rich has just presented, please feel free to put those questions into the chat panel to the right of your screen. We will now hear from Dave Bell, and Dave is the South Atlantic account manager with Creaform. He will now introduce you and demonstrate some additional 3D scanning products and software.
All right. Good morning, everyone. Again, thank you, Melissa, for the introduction. My name is Dave Bell. I'm the account manager for the South Atlantic region for us here at Creaform. That means I'm covering the Carolinas and down to Georgia, whereas Rich is supporting Virginia, Maryland, and north up that direction. So I'm going to dive into some of the technical stuff and show you exactly how these scanners work. We're going to show two scanners this morning, the Handy Scan and the Metra Scan. So let's start with the Handy Scan. This is it. Weighs 2.1 pounds. This is a laser scanner. So we have laser cross emitters right here in the middle and two cameras that see those lasers projected on the part. And that's what, through stereo vision, creates the 3D model. Now, these cameras look sort of unorthodox because they also emit infrared light. Since our systems are purely handheld, they're not fixed on a tripod and they're not on an articulated arm that is sort of trying to figure out where the scanner is. This scanner knows where it is by using targets. And when I say targets, I mean these retroreflective stickers that the Handy Scan requires in order to know where it is. It's just like constellations in the night sky. When the cameras can see these targets, it's able to very accurately know where the scanner is relative to the surface. All right, so enough talking. Let's just turn on the scanner. We'll tell it to start a new scan, and we'll start scanning. Now, the Creaform software generates this mesh model in real time. So you're able to easily see everywhere you've scanned and everywhere you still need to scan. And if you need to stop or look at the model, rotate it on screen to see where it is, or even leave the part and come back hours or even the next day to continue your scan, you can always resume. Now, as Rich said, the accuracy of the Handy Scan Black Elite that I'm using is 9/10 of a thousandth of an inch. All right, let's say our scan is complete, and let's look at what we have. So I'm going to click on the model to select everything connected to the point where I clicked and get rid of everything else. I don't normally hold parts while scanning them, but it makes for an effective demonstration to understand the scanner simply knows where it is relative to the part and the targets on the part. So it doesn't matter if we move the scanner or move the part, everything will be aligned. Now I'm going to turn on the triangles here, and you'll get an idea of what we've captured. So you see this very regular spacing of triangles. And so this is because I've set the resolution of my scanner right here to 39 thousandths of an inch. And that means you'll see approximately 39 thousandths between each vertice of all of the triangles that I have. Now this scanner will go down to 4 thousandths of an inch for spacing. So almost 10 times higher in one dimension. But if I just captured 20 megabytes of data on this one part, if I was to scan it at the highest resolution possible, that would be 10 times more data in X, 10 times more in Y, 10 times more in Z. I could potentially have 2 gigabytes or more data on this one part. So you really need to match your resolution with what your needs are. Now, the other thing we're looking at here, our initial triangulation, this is a preview model. This is showing you where you've captured data and where you might still need to. To get to my final mesh, I just click the Finalize button, and two things happen. One, it takes all those targets, deletes them, and fills them in. The other thing it does is it looks back at the scan data, and it will use more information if it has it available in regions of higher curvature. So here you can see that the triangulation is sparse in flat regions, but it's more triangles along these ribs and in all regions that have more curvature on the model. So that just makes it so you don't have to scan the entire model high resolution and then thin it down to get something lightweight. The software will sort of automatically increase resolution in regions that need more data. All right, let's look at another scan. Because you might be thinking, well, that works great, but all my parts aren't matte gray. They're sometimes shiny, they're metals, things like that. And these sorts of things have always been difficult for 3D scanning. So here's a chromed plastic hubcap. And so this is unable to be scanned at all by some scanners unless you spray it with a powder or something like that. But with the blue lasers and the Creaform scanners, we can scan this material. Now, I do need to adjust the scanner settings for something like this. But again, the scanner takes care of that for me automatically. I just pull up on the back on the scanner. I click on Auto Adjust on the on-screen menu. I point it at the part and move it around and let it figure out how it needs to adjust its settings to best scan this surface. Again, start a new scan. And now I can scan even highly reflective surfaces without any treatment. So this will work for machined metals, dirty surfaces, shiny surfaces, dark surfaces, can all be scanned without any treatment. And again, that's just the preview mesh. It looks even better when we finalize. All right, so that's the handy scan. Rich also told you about the Go scan, which I won't demonstrate this morning, but this is the structured light scanner that can operate without targets if there's enough locking geometry to use it. It can also capture color, and it's another great portable scanner. But its downside is since it doesn't use lasers, it can't capture shiny and reflective surfaces as well as the laser-based solutions. So if you're working with shiny or machined metals, we highly recommend the lasers. If needing color is part of your requirements, then this is a great way to go. All right, we're now going to switch over to just talking about the Metroscan, which is exactly the same, but completely different. So the Metroscan has exactly the same accuracy as the handy scan. It's accurate to 9/10 of a thousandth of an inch, and it uses laser cross emitters and 2 cameras to scan the lasers on the part. It'll scan shiny parts and dark parts and everything else. But the difference is these cameras will look a little more orthodox, like regular cameras, because this scanner is not looking for targets. The targets are placed in this frame around the scanner, and that frame is seen by what you see here in the background, called the C-track. The C-track is a stereo tracker that tracks the position of the Metroscan in a 16 cubic meter volume. So that means that small parts, large parts, we can scan all of these things without placing targets on the part because the targets are on the scanner and tracked by this apparatus. So let's show you exactly what that looks like. We'll go back to our software. I've got the Metroscan connected. And this is the Metroscan. Now behind me, I have a dented car door. And again, this is a black, shiny surface. And so in order to scan this part, I'm going to have to, again, adjust the settings of the scanner. I just hold down the on-screen button. I go down to Auto Adjust. Point it at the surface, let it automatically adjust its parameters for this particular type. You can even see in the camera that it's increasing the laser power. And then I just hold down the button to make a new scan. And I start scanning. In this particular example, I'm scanning at exactly the same resolution that I was using with the handy scan, but now I can scan a very large area without any targets. And so we commonly see this at our larger automotive and aerospace customers, also heavy equipment and large manufacturing processes with large tools and dies that need to be able to scan large parts or assemblies without having to put targets on all the time. All right. And we can clearly see the dents in the door now that I see it on screen. A little harder to see in the video, but it's a very damaged door. I'll do a similar process here that we did with the first model we processed with the handy scan. I'll just select all the data connected to where I clicked, and we'll let that finalize. Now I want to talk about another component of the MetraScan C-Track system, which is the handy probe. This is a probing device that is handheld and wireless. We have a standard Renishaw probe on the end. This is a 6mm ruby tip on the end, but you can use almost any standard Renishaw probe. And this probe is tracked in space. So you can see on the right-hand side of the screen, my digital readout for this probe. So if I take the scan we just made and I'll take it into our inspection package. Let's zoom in here. You know, if you want to do quick measurements and you don't want to scan an entire part, you can do that with the handy probe. And it again has on-screen menus that I can click on the device and say, all right, I want to do a quick measure of a distance between 2 points. I will place the probe in one point on the door. I'll put it in another hole on the other side. And you'll see that I can make point-to-point measurements. I can define planes, cylinders, spheres, all the standard things you would expect from a probing device, but completely wireless, and it works in the full 16 cubic meter volume that we have for the MetraScan. And it's a very useful tool when you're trying to just take some simple measurements or features. And you can use the handy probe without doing any scanning at all. All right. So quick review on the MetraScan. You can scan small parts. We can scan large parts. And again, things we say about Creaform is it's accurate, it's portable, and it's easy to use. And a lot of times people say portable, well, that means that I could take it to a supplier site or something like that. I could take it to another facility and scan there. And that's completely true. But also portable means you can take it to places in your own facility. You don't have to bring all of the parts into the CMM lab or the quality lab in order to measure them. Sometimes you bring the scanner to the part. In this case, in this picture, this is a very large tool that is probably not going to be easily moved into a QA lab. But we bring the scanner to the tool to do scanning. Again, we can scan all sorts of surfaces, shiny surfaces, light surfaces, dark surfaces. There's even an HDR mode you can use so that if you've got black and white at the same time, it can alternate its exposure every other frame 80 times a second, and you can capture the whole thing in one pass. And again, we talk about portability. Some things you could never take into a room, especially when you're scanning almost inside of a room, like inside of an aircraft. But again, we can set up the MetraScan or the handy scan and capture these interiors to capture geometry that is really defining and capturing the as-built conditions of these things. We can scan assemblies, door openings. Again, aerospace and automotive are great applications for this. But anyone who's producing parts can get benefit from this technology. And again, here's a picture. I'll move my camera out of the way a little bit. showing that, we can scan an assembled engine while it's on the aircraft just by placing the C-track next to it and using the MetroScan to scan in that area. So, little review. What can it be used for? Concept design, tooling design, reverse engineering, quality control, scanning assemblies, things in production, aftermarket parts. This field has just exploded in the last 10 years. That, doing aftermarket parts without 3D scanning is just handicapping yourself. You can scan parts, make new parts, replacement parts, alternate parts, parts that are no longer available. It's a great market for 3D scan. All right. If you're doing inspection, it seems like a no-brainer that you want to automate that inspection. And Creaform has introduced, using the MetroScan that you've just seen, a fully automated version of that we call the QBar. This is a full robotic system with the same MetroScan and C-track technology we just demonstrated that can automate the inspection of your parts. So here's a complete cell. It's ready to go. We bring it in, we drop in the whole system, and in 2 weeks, you'll be up and running, installed, setting up your parts for scanning, and getting results. The programming of this system is all driven by CAD, and it can be done by someone who has no familiarity with robots or automation, because we're not using the teach pendant to try and define positions and orientations of the scanner one by one. You're using the CAD model to define how you want to scan a part. You click on a few surfaces, it knows how the MetroScan works, it knows how the robot works, it knows not to collide with your parts or fixtures, and it can automatically generate the robot programs defined to scan these parts. And then once that program is done, you can scan 1 part, 10 parts, 1,000 parts, or just repeat over and over again whatever you need to scan. Now, if your parts are not quite as large, or you're looking for something without the same footprint as a large industrial robot, last year we introduced our MetroScan system on a cobot system. So this system will work side by side with your operators. Again, exact same technology. MetroScan, C-track, tracking the scanner. But if it runs into someone, it's perfectly fine. The system will simply stop and then resume when you tell it to. So you can use this system, again, side by side with human operators, the goal being the same, to automate scanning and inspection of parts by automating the scanning process so an operator doesn't have to scan it over and over. So you sort of choose the application makes the most sense for you. A portable system and a system that is robust and you can scan whatever parts you want with a handy scan or a MetroScan, or a fully automated system with a MetroScan on a robot to scan your parts over and over. All right, so we'll stop there for a second and now let's talk about what we can do with this scan data. So our market is split almost 50-50 between reverse engineering and inspection. And so I'm just going to walk through an example. This one's pre-recorded of a simple reverse engineering task. And so Creaform has 2 softwares, VX Model for reverse engineering and VX Inspect. And so what I'm showing you now is VX Model. And we're starting with this simple pipe model to do a reverse engineering project. So VX Model allows you to capture features easily on the part. And so we'll do this similar to how you would model it yourself if you didn't have scan data to go on. So I can extract these planes, I can define planes to be parallel to one another. And what I really want to do here is extract this profile at the end so I can send it over to CAD to construct a new CAD model. So I make a plane in between the 2 planes here. I'm going to cut a cross section using that central plane in the middle. And so now you see all the entities that I've created in VX Model. I've got the planes, I've got the cross section. And so I can save this as IGES or STEP and send it to any package. But for SolidWorks and Solid Edge and Autodesk Fusion 360, I can send all of this stuff just directly over to the CAD package with one click. And so it's a very easy workflow to go back and forth between VX Model and your CAD package to make things happen. So here I've brought in that section. I'm extruding up to one plane, down to the other plane, and I've started to make my solid model of exactly what I need. Now keep in mind, I didn't do any measurements to say how big is this, where is this? I'm just using the scan data to drive. So now I'm going to do the same thing on the other end. And for the sake of time, I've sped up a little portion of this video because we're essentially doing the same thing we did on the other end. I've defined my planes, I cut a cross section, I send it into CAD, and we extrude those ends. Now you can see a real timer in the upper right-hand corner of the video that shows the total length of time for this video. We're only going to spend about 6 minutes on this, but the total time is closer to 14 minutes start to finish. So here in this little inlet on the side, I'm again cutting a cross section to get the dimension, but on this case, it is a circle. So I'm going to fit these to be perfect circles and send these circles over to SolidWorks so that when I do use those to make an extrusion, it'll be perfect circles that I have. Now, the hard part on this model is the sort of organic freeform shape that we have in the middle. So this would be very challenging to model and actually get an accurate surface with any conventional tools. Well, we're going to use the scan data to the best of its ability. And so the first thing I'm doing is, now that I have the ends modeled, I'm going to chop off the ends. I need to get rid of the inlet as well. So I'm going to cut that out as well. And we use the polygonal editing tools to fill in these regions. So just with a click, I can fill it in. Here's an embossed label that I'm going to select around that and defeature that. And it will automatically replace the surface with a logical continuation of the surrounding area. Now I'm also going to take these ends and extend it, because as I model it, I want those ends to extrude beyond those solid ends that I've made. And we'll come back to that as we start putting it together. Now, how do I make a surface of this? We have a function in VX Model called auto surface. And this will create a patch network on the model that is essentially continuous NURBS patches that come together to define this. So I've converted it from the STL mesh into an actual CAD representation of a surface. Now that I have my 3 extrusions and that surface, I can use the intersect command in SolidWorks to join them all together and to make this solid model that you see. And we know that it's a solid because I can add fillets in between these different items to get closer to my final model. But again, now I have a solid, and a solid wasn't my intent. I need to make a tube of this thing. It's because the original model was a tube. But if you've worked with complex surfaces in CAD and you try to make offset surfaces from them, you know that sometimes those offsets can fail in your CAD package. Making offset surfaces when you're in the polygonal world, like we have in VX Model, is much more robust. So here I'm using the offset surface command in VX Model to make an offset surface from the outside that is exactly 1.4 millimeters from the outside model to the inside. So here you can see those 2 surfaces. So I'm going to view just that inside surface now, and we'll use the same tool we had before. We're going to make an auto surface of now the interior wall. And so that's going to, again, generate this organic NURBS patchwork that precisely matches that complex organic shape. We will send that over to SolidWorks, and now we can use that interior surface to cut away the inside. You just have to select that surface, and it will, using the surface cut command in SolidWorks, we cut out the inside, and we'll be back to having this tube model. And again, we've gone from the STL triangulated mesh to now a complete solid model inside SolidWorks. One more thing to add here, a little extruded cut using that inside circle on the inlet. And so we can just blind extrude high, blind extrude into our model, do a cut. And so now we've got our final model. And again, looking at the timer in the upper right of the screen, it was right around 14 minutes total from end to end to generate the whole model. And you can apply this similar workflow going back and forth between VX Model and your CAD package It can be SolidWorks, it can be Inventor, it can be Fusion 360, and it can be Solid Edge. But if you don't have one of those packages, you can do exactly the same process by exporting IGES or step files instead of having that direct transfer link and doing the same process we just showed here. All right. So that's the reverse engineering world. Let's start talking a little bit about the inspection world. And I'm going to show you some of that live using the software. So let's just make a new session here. And we will look at quality control. We'll turn off the scanners for a minute. And now I'm going to import a simple model. This is a scan made. This was made with the handy scan. And it's just of this sample part I have from a long time ago, a plastic part. So once we have this scan data, and again, it's just triangulated data, what can I do with this? So the very simplest thing we could do is take a measurement. So I can say measure distance from this side to this side. I got 7.540 inches. Well, what if I measure that again? If I say, all right, let's do another distance measure, and I'll measure from here to here. Well, now I get a slightly different measure. And this is exactly the same if you were to pick up this part and have one operator use a pair of calipers and measure it and use another operator pair of calipers. You might get slightly different numbers. Now, to be fair, what I just measured was not really a caliper measurement because it was measuring the full 3D distance between those 2 points that I picked. So we're going to need to use our virtual caliper to measure. So the first thing I'm going to do is extract a feature plane, which I'm just going to click on this side, and with one click, it finds all the planar elements connected to where I clicked, and it'll fit a plane there. And now that I have that plane, I can use its normal direction for a caliper measurement. So I'll just use these calipers. We'll say that my axis is the axis of the plane I just made, and I'll measure a point from this side to this side, and I get 7.553. Let's do another measurement on the other side of this part, 7.554. So I'm definitely more repeatable, but again, the measurement depends on where the operators click. You can even see on this part, there's even some indentions on the plastic part that if you ended up taking a measurement on the inside, it's going to have drastically different numbers for what that caliper measurement is. So let's again do something a little different. Instead of just picking a point to measure the distance between here, I'm going to measure the distance between two planes. So I'll fit a plane on this side as well. And I'll measure the distance between those two planes. So the distance from plane 1 to the center of plane 2, and I get 7.545. And if I recreate those planes again with the same parameters, I'll get the same number, and it becomes much more operator independent. Now, I was talking with a customer yesterday about, well, I could just do that with a pair of calipers and just have the number. And that is certainly true. These operations definitely work on complex parts and things that you can't measure with calipers, but there's a lot of benefits to scan data as well. Once I have this scanned, I basically have a virtual copy of the model that I could send it remotely to someone in another state to look at the data, maybe even another country. I can also fully capture that data. So maybe I only had the part in my QA lab for 30 minutes. And then they come back tomorrow and say, hey, you didn't measure this. Well, I've still got the data. So if I need to make more measurements on this part, I could click to fit a cylinder, another cylinder, and then I can measure the distance between those cylinders. And it doesn't matter if I make that measurement right now after having scanned the part, or a month from now, or a year from now. You basically have a digital duplicate of the part at that moment in time, and you can go back and take further measurements on it as required. All right, this is sort of the manual method where you've got a part, you scanned it, you want to extract some information on it and see what you have. That's not the most common method of doing inspection. Usually we have a CAD file that can drive what we're trying to do and also give us nominal information. So let's look at that same part again, but this time I'm going to bring in the CAD model. So here's the CAD model of this part, which we can call perfect. And here's our scan data again. And the first thing I do is align these. So in this case, I'm just going to let them do a surface best fit. So now I have my scan data overlaid with the CAD model. Now I did a surface best fit. We can do RPS alignment. We can do entity-based alignment, 3-2-1, whatever type of alignment you need to do driven by your requirements. After I have the data aligned, the very next thing I do is compute a color map. These sort of things are really not available to do in the CMM world because they only have sparse data, and we have this more complete data of what we're doing. So let's pull this back up. Oops, no. And so the color map can show us, and we can adjust the color spectrum, the deviations between the CAD model and our scan model. So in this particular case, I always see greater deviations at the bottom of the wall on this model, almost all the way around. And that's because the original CAD model has straight walls up and down, and our model has drafted walls from the actual physical part. And that's why you see these deviations going top to bottom that are higher at the bottom. Now, the CAD model can also help us to create features and do other things. So, for example, when I create a plane in this example, when I click on the model, it's actually using the CAD model as its reference and then finding all of the scan data that corresponds to that plane. And it automatically made a flatness GD&T call out for me and shows what the value of that flatness is on that plane. I can do the same with a sphere by clicking on the sphere of the CAD model, and it finds all the scan data according to that sphere. And I can even construct planes sort of, I could say, all right, give me a plane that's offset from the first plane I made, but then goes through the center of the sphere. So now I've got a plane directly in the middle of the model, and I could use that plane for cross sections. So we'll just say plane 2. Okay, maybe we want to fit some lines on that cross section, which again, fitting lines uses the CAD data behind the scenes. So when I fit, I just have to click once and it knows where that line is in CAD, and then it extracts that data in my scan data. So there's 2 lines. And if I wanted to know the distance between them, let's again look at the cross section. And we'll look at the distance between line 1 and line 2. And so it shows me that in the nominal model, it's supposed to be 59 thousandths. I'm measured at 60 thousandths. And so it's just slightly different. And we can assign tolerances for that to show how much it will vary and whether it passes or fails that dimension. So when we have a CAD model, we can use that CAD model to drive defining an inspection process. But the value of this is that you only have to do that once. So let's pull in a full model that I've already defined an inspection on the CAD model for what I need to analyze. So here's a full inspection. It's got cross sections, it's got lines, it's got tolerances defined, it's measuring cylinders. And so here's where my initial model was. I'm going to go back here and say replace this mesh. And we're going to replace it with a new scan. And so once I do that, it's going to take that scan, it's going to align it using the alignment techniques I have defined in the process, is then going to inspect everything that I've defined to be inspected. And all I need to do is say quick report. And now I'm going to get a whole new report generated. And all I had to do is drop in the new scan. And so my report has all of the data that I've defined to be in the report. Screenshots of deviations, cross sections, dimensions, pass-fail information. I've found some cylinders and I'm measuring the position of the cylinders. And if they're out of tolerance based on the tolerance that I've specified, it'll highlight in red showing how much that are out of tolerance. If they're close to out of tolerance, here I have a 150 thou tolerance, or I guess this is millimeters, so 150 microns. It's out by 143, so it shows that it's near the end of the tolerance, but not quite out. There's another one that's out by 17. So again, if you have to measure 5 parts, 10 parts, 20 parts, you're really only defining that inspection process once on your CAD model, and then you get a new scan, you drop it in, and you get a new report. The latest software we have also has batch processing. So you have a collection of 20 scans. You can just auto process all of those, get reports for each one, and you'll be good to go. And that's inspection. So again, we show VX model for reverse engineering, VX inspect for inspection. But I would like to say that Creaform's output from the scanning is compatible with every other package in the market. So if you're using software from Polyworks or using software from Geomagic or using Metrolog, you can know that the STL mesh output that we get from the Metroscan, the HandyScan, the GoScan, it's going to be compatible with all those softwares, and you can use them in some cases with direct plugins in those softwares, or you can use our software packages to do your inspection and reverse engineering. All right, that's what I had for the software side. I'll send it back to Melissa.
Thanks, Dave. That concludes our demonstration segment, but we'd like for you to stay with us for a little bit longer for our question and answer. Also, we're going to go through contact information for your customized demonstrations, if you so desire, and some upcoming learning opportunities that we'd like to share with you. But we do have a question in our chat panel, and Dave or Rich, you can decide who can answer this for us. They're asking, can they fix the Handy or the Metroscan and then rotate the part around the scanner versus vice versa?
So you can do that. So two very different things there. One is the HandyScan. And so just like I showed in my example where I have targets on the part, I can fix the scanner and move the part and it will scan just fine because it's just tracking the position of those targets that are on the part. So as long as you have those targets, then you can absolutely move it. In the case of the Metroscan, it is possible to use the Metroscan and move the part. But I basically showed you that the Metroscan doesn't need targets. But the truth is the C-Track can use targets. So for example, if I'm scanning something that is 40 feet long, that's bigger than my scanning volume with the C-Track. So the method we use is to place some targets down the length of that object and let the C-Track see those targets and position itself. So we can position it at the front end of that large part, in the middle, and the end, and it will always maintain its position. And it will do so accurately because it has built-in photogrammetry. We could use that same concept to move a part relative to the Metroscan as long as we had some targets that are defining how that part is positioned relative to the C-Track, which is also measuring the Metroscan. That's a pretty complicated question. I hope I got an answer for you. If not, please do reach out to us and let us know if we can help.
Great. Thanks, Dave. So that is the question we had. So we're going to move on, and I'm going to remind everybody that everything you heard about today, you can find in handouts, and click the handouts button to the right of your screen, and you can download the handouts, product information. You're also going to be emailed this information through the email that you gave when registering, and a link will be provided for a recording of today's session. Now, if you want to schedule a time for a customized in-person presentation of any of the products you saw today, please contact Blaine Mead, our CEO of Master Gage and Tool. He will coordinate with your salesperson in territory for Master Gage and Tool, along with Creaform representatives, to schedule an in-person demonstration that can be customized to your application. Also, as mentioned, we do have some additional learning opportunities coming up in the next few months. September 14th, we're offering a measurement uncertainty webinar. Again, that's a virtual basis with an industry leader, Kim Merlo. You can learn how to achieve reliable results through uncertainty budgeting. We are also going to offer Kim's services through Master Gage for any customized uncertainty budgeting needs you might have. You can contact your Master Gage and Tool salesperson for that. September 24th, we're going to offer a GD&T Basics Introduction webinar presented by GD&T Basics. They're out of Greenville, South Carolina. And as a follow-up to that, we're actually going to be offering November 2nd and 3rd an in-person GD&T class, more in depth, and that's going to be with another trainer from GD&T, and it's going to be at our Danville, Virginia location, November 2nd and 3rd. You can check out all of these learnings. You'll see on the screen, you see there are QR codes that you can scan and get to our registration page for any of those learning opportunities, or go to our website, mastergt.com. Check those out along with all of our e-commerce offerings. But if you need anything, you know that you can contact your outside salesperson or anyone at Master Gage and Tool for any of your specialized gauging needs or calibration needs. We thank you for participating in this event with us and look forward to your participating in any of our future events. Thank you and have a great rest of the week.